Okay guys, today is interpreting data, and this is really summing up a lot of what we've done all week. Alright, one vocabulary term, margin for error. Pause the video, copy that down. We'll talk about that in a few minutes here. I'm going to go right on to example. Alright, here's example 1. A tennis industry association wants to estimate the number of Americans 12 years old and older that played tennis at least 4 times in the last 12 months. Alright, this association conducts a survey of 1,000 Americans. Obviously, that is not all the Americans 12 years and older, but they are going to survey 1,000 of them, finds that 62 of them played tennis at least 4 times in the last 12 months. Of all Americans 12 years and older, we want to estimate how many played tennis at least 4 times in the last 12 months. And it tells you there are about 237 million Americans 12 years and older. Okay, so here's the process we're going to do. All right, we're going to estimate, so this is going to be about, but first we're going to find the percent of Americans that were sampled that play at least 4 times the past 12 months. So up in the reading here, they said 62 out of 1,000. Okay, that's a good old ratio. If I want to turn a ratio or a fraction into a percent, I just simply divide. So you divide the top by the bottom, and you get 0.062. Now we want a percent. All right, right there we want a percent. To turn a decimal into a percent, we all should know this. Multiply by 100. Multiplying by 100 takes this decimal, boop, boop, turns it over 6.2. Turns it over to the right twice. Okay, so that's my percent of Americans out of what I sampled. Okay, now we only sampled 1,000, so we're going to take that 6.2% and we're going to extrapolate it. Okay, we're going to expand it to represent the entire population. Okay, so I'm going to take 6.2% of 237 million. That is a lot of zeros. Not my average salary. Okay, so whenever you take a percent of something, of in mathematics means you multiply. Alright, 237 million. And whenever you use a percent and you're doing some math on it, you have to turn it back to a decimal. So actually, I'm going to use that decimal. And what I get is about 14.7 million Americans. Okay? So when I actually multiply that, I get a pretty big number. Okay? So pretty easy, pretty straightforward there. Okay? There's example 1. Let's skip right up to example 2 here. Alright, we'll turn that off and bring down example 2 is right there. Okay, a survey of random sample of voters predicts that a candidate A will receive 53% of the votes and that candidate B will receive 47% of the votes. Okay, the margin of error is plus or minus 4%. Okay, here's that margin of error thing we mentioned earlier. Alright, what this means is that if I am candidate A and I am to receive 53% of the votes, but there's this plus or minus 4% margin of error. That means I could go up to as high as 57%. All I did was take 53 plus 4. Or I could go down to 49%. I took 53 minus 4. All right? I'm going to end up, if I'm candidate A, I'm going to end up somewhere in between, or right at 57, or right down to 49, or somewhere in between. I could be 52%, I could be 50%, etc. Okay? Candidate B, same thing. Candidate B, they said, is going to get 47% plus or minus 4%. So he could go up, or she could go up to 51%. Or, and I just took 47 plus 4, or they could go all the way down to 43%. Okay? So the question is, can you predict who will win? Well, no, you can't, because this person could get 56%. Okay? And that means this person would get 44%. Okay? In that scenario, candidate A won. But what if candidate A got 49%? That means this person went up to their max. They got 51%. That means candidate B won. All right. So in this scenario, you can't predict from this statement or these statements up here who won. Okay. So that's all it means. No big deal. Not a really big deal. So this is checkpoint 1 that I'm going to turn on right now. Okay. So you want to pause it, put your answers on there because my answers are coming up. Okay, so here's what I get for candidate A and candidate B. You can definitely predict in this scenario that candidate A is going to win. Oh, look, I found a new tool. Look at stars for these people. All right, so I definitely could predict that candidate A is going to win because they can go anywhere from 51 to 57%. No matter what happens, they're going to get more than 50% of the votes. All right, this person over here cannot get more than 49%, so they are the loser. All right, so that person has to win. Okay. All right, one more to go here. Well, one more and then a checkpoint. We're going to turn that one off and turn that one on. Okay. This one really is just kind of summing a lot of things up that we've done. Larger families more likely to own a dog, this one is called. And it says a recent survey of 1,012 American households by telephone found that the larger the family living in the household, the more likely that the household has a dog as a pet. Each household was asked to, or if they owned a dog. The results are shown below. Okay, so here's the little things that we pick out from this. All right. First of all, the selection or the survey was, I would say, a random survey. Okay, because they surveyed by phone and they went across America. All right, the way they describe it here. So it's definitely random. I've got this little pointer right here. I'm going to put the words over here because I have more space. I would say definitely an unbiased question or not biased. Okay, because it's a very simple question. Do you own a dog or not? And then how many people are living in your household? Okay, so there's no encouraging one way or the other. Alrighty. As far as this down here, I would say that the one thing I don't like about this is the list of household sizes is limited. Okay, I really have a hard time believing that out of 1,012 American households that you had no more than 4 people in the household. My family has 5. Okay, 3 kids and mom and dad. And I gotta believe that there are more people. And I really believe if you included persons with 5 in the household or 6 in the household, or families with that many, that the number of dogs might go, or if they had a dog, would go down. You know, so that's the one thing I don't like about the way they represented this data. I noticed that they don't do any margin of error. Okay, no margin of error down here. So that's kind of a bad thing. Usually you want a margin of error. The only other thing I put right here is that the good thing about this graph is it's a very simple graph. Okay, and this is for this little pointer right here. It's not misleading with the graph. There's no jumps in the representation. There's no like bars that are way out of whack with each other to encourage you to think, oh, that's a huge amount compared to the others or anything like that. It goes up by tens, which is very easy. This goes up by 1. So the graph itself doesn't appear misleading. So it is basically a good graph. All right, so that's just kind of summing up a bunch of the stuff that we've talked about over the last week. All right, so that's about it. We're going to do some similar things with some exercises tomorrow. So thanks for watching. Hope you got all this, and have a good night.